Talk about plotting, and we're going to do it using Matplotlib. Matplotlib will now be the second of the third-party packages that we learned, the first one having been NumPy. But there are many other packages out there for plotting. There's Plotly, there's Seaborn, and there are many others. So the first question is, why Matplotlib? Why not one of those? The main answer to that is that it's the one that I know best. I do basically all of my plotting using Matplotlib. But it's also the original plotting package. It dates back to 2003, and it remains the most popular. So this is evidenced by a recent article in medium.com and written by Tobias Talaj, entitled Most Commonly Used Python Libraries. And in this article, Mr. Talaj downloaded a bunch of packages or a bunch of repositories from GitHub and did an analysis and found that amongst the visualization libraries, Matplotlib was by far the most common, and followed by Seaborn and then Plotly and then many others. So that's the reason that we're really going to focus on Matplotlib, but also because the structure of Matplotlib, it being the oldest one, has been the inspiration for many of these others. So if you can understand Matplotlib, it should be pretty easy for you to pick up these other ones. Furthermore, Matplotlib really does a lot of things pretty well, and it gives you a lot of control over the different aspects of your plots. It comes with heavy inspiration from MATLAB, so if you know MATLAB plotting, this will be very natural to you. But it doesn't do everything. So, for example, if you wanted to make an interactive plot where you can click on a particular piece of data and then it opens a pop-up window with some information, and you want to take that and you want to embed it in a web page, then maybe Matplotlib is not the best, and in that case, you might go with Plotly. As I said, if you know Matplotlib, Plotly will be easier to pick up. So let's get started. Before we begin, I'd like to quickly go over the different types of plots that are out there. You have line plots, bar plots, surface plots, scatter plots, histograms, and of course many, many more. So a line plot is one that you'd use when you have one quantity that depends on another quantity, strictly depends on another quantity. So you take the independent quantity and you put it on the x-axis, and then the dependent quantity would be measured vertically. A good example of this is the example from the last video where we had the angle, the angular speed, and the energy of the pendulum. These three quantities depend strictly on time. And so they're a function of time. So you can plot them with a line plot. Related to a line plot is a bar plot. The difference between a bar plot and a line plot is that in a bar plot, the independent quantity is discrete valued, so different categories instead of a continuous value like time. So in this example, perhaps A, B, and C are the grades for students in a class. So this is indicating that we have, say, 38 A's and 28 B's and 21 C's in this classroom. Now, a scatter plot is somewhat different because we use a scatter plot when the two quantities are not strictly dependent. So this is used a lot when we have noisy data. Let's say, for example, we have taken measurements of temperature and humidity in a room. So we could take those measurements and plot them. So we have temperature, we put temperature on the x-axis and humidity on the y-axis, and then each point in the scatter plot would be a particular measurement of temperature and humidity. Now, a histogram is very closely related to a scatter plot. Even though it looks superficially like a bar plot, these two things are actually quite different. They're not related. a histogram is related to a scatter plot because it's also a way of visualizing noisy data. In this case, in the case of a histogram, we're taking just one of the measurements, say temperature, and we are plotting many different measurements of temperature. Let's say we have all the measurements, and if we were to put them on the temperature axis, we'd have so many data points that it would be difficult to distinguish. So that would not be a good plot. Instead, we bin the temperature axis, and we count within each bin how many data points we have. And then the height of that bar is going to be the number of data points in that bin. So in this case, we have about 80 data points in this bin and 100 in the bin right next to it. So a histogram is very closely related to the idea of a probability distribution. Finally, a surface plot, that's actually more closely related to a line plot. These four, line plot, bar plot, surface plot, and histogram, are what I would call a 2D plot. Then a surface plot is an example of a 3D plot. See, you can take a surface plot, it kind of lives in 3D, and you can rotate it around. A surface plot is related to a line plot because in a line plot, whereas you have one independent quantity, in a surface plot you have two independent quantities and one dependent quantity, which would be measured vertically. So a line plot is something like a function from the real numbers to the real numbers. A surface plot would be something like a function from the plane, from R2, to the real numbers. Now I'm going to show you a pattern that you can use for plotting in Matplotlib. Now, this is just one of the ways that you can do things. It happens to be the way that I do it, but there's not really a correct way of working with Matplotlib. Everyone seems to have their own preferred approach. So you might find some other way that you prefer, and that's just fine. So it begins with importing matplotlib.pyplot as PLT. We import the pyplot subpackage of matplotlib, and we alias it with PLT. So whenever we call matplotlib or make a call to matplotlib, we're going to prefix it with PLT. We create a figure using plt.figure, and that's going to make our empty canvas, and it's going to make it of whatever size we specify. And say we want to put on this a few figures. So we want to put one here, and a tall one like that. Then for each one of these, we are first going to create it and place it using plt.subplot. Then we are going to add all of the graphical elements. So say a line and maybe a scatter plot. Then we can add a legend. And then we can customize everything. The limits, the legend, the ticks, the grid, the spines. We can even add a title to the axes. Then we do that for all of our axes. And at the end, optionally, we can save this figure to a file. So here's an example. As I said, I begin by importing things. Then I've created some data. It doesn't really matter what. Then I want to plot things. So I call plt.figure. And I pass in the figure size. In this case, I want this to be 8 width and 4 height. So I assign the tuple 8,4 to the fig size argument of the figure method. That is going to give me back a figure object. And I only really need that object if I want to save the figure. You can see I don't actually use it here to create the figure. Anyway, now we're going to make each one of these axes, and we'll start with this one. We create it and place it using the subplot method. And, well, this is the interesting part. So what we're passing in here, we're passing 2, 2, 1. That is going to identify this upper corner. How? 2, 2. The first two entries tell it the grid size. So this has 2 rows. So 2 rows. and 2 columns. And then we're saying we want to place the figure in the first position, or the axis should be the first position. And we number these at the way we read. So 1, 2, 3, 4, from left to right and up to down. Then that gives us an axis object, and we can add elements by calling plotting methods on that axis object. So then we do add all of our elements to our customizations and go on to the next one. This one is saying 2, 2, 3. That means that I want to put a plot in the 3 position of the 2, 2 grid. And then, let me clean up here a bit. The last one, this one, we make 1, 2. That means a grid with 1 row, and 2 columns. And we want to place the plot in the second entry. So this would be the first entry. This is the second entry. So that's how the subplots method works. Now we're going to customize our plots. I'm going to focus on the plotting method that made this line plot on the right. And on the right-hand side of your screen, I am listing all of the customizations you can make. So, for example, we can set the line style to be a solid line, a dashed dotted line, or a dotted line. And we do that by passing the line style keyword argument into the plot method and setting it, for example, to this double dash string. When we do that, we see we get a dashed line. Now, for different plotting methods such as histogram and scatter, they will have their own list of customizations. So when you want to customize those, you should look up in the documentation what are the customizations you can make. I'm just focusing for now on the plot method. All right, the next thing we might want to customize is the width of the line. So we pass in line width, and we give it some positive integer. So if I give it 7, we see we get a very thick line. So let's pass it in something more reasonable, like a 2. How about the color? We pass in through the color argument the name of the color that we want the line to be. Let's say I want it to be red. I just assign the string red to the argument color, and now we have a red line. So what are the colors that we can mention by name? Here is the list. As you can see, there are many beautiful colors that you can use. And so how about, let's use this one, Dodger Blue. Dodger Blue. So I am going to pass here Dodger Blue. And now we have a blue line. Very nice. So next thing is the markers. We can add a marker for every point along the line. And we can say what type of marker we want. So we can use a dot marker, an O marker, a star marker, etc. There are many markers we can use. So let's try this O marker. Okay, so it's added a sort of a circle to each point. And there are 50 here because we have 50 points in our array. We can set the size of the marker, the face color, and so forth. And I have this already typed out. So we have an O marker. Let's set the size to, say, 10. The face color is the color of the inside of the marker. Let's set that to lawn green. And then the edge of the marker, that is the perimeter, the outline, we can set that, say, to black. And then the width of the edge, set it to 2. That's what that looks like. Okay, very nice. Let's try other of these markers. The dot, that's simply a smaller circle. The asterisk is a star. The P is a plus sign. The X is an X symbol. The S is a square. D is a diamond, and so forth. So there are many markers to choose from. We'll finish up our plot by customizing the axes. In this example, I have a figure with a single plot in it. So I can make that using subplot and passing in 1, 1, 1. But since those are the defaults, I can also just leave it empty. Now I've added a couple elements to this. I have a line plot and some scattered red data. And on the right here, you see all of the customizations that I can make. So I can set the limits of the plot. If I wanted, for example, to focus in on this region with x from 2 to 4, I would say ax.set xlim and pass in 2 to 4. Let's say I want the y to go from -1 to 1.5. Then I put -1 to 1.5. All right. Now the ticks. The ticks are these labels that you see along the x-axis and along the y-axis. Right now, the ticks for the x-axis are set to 2 to 4 every 0.25. And if I wanted to make that every 0.5, I would say ax.set xticks, and I could pass in a list of the ticks that I want, etc. Or I could also just use np.arange and pass a range from 2 to 4.5 every 0.5. So those are the x ticks that I want. We'll leave the y ticks the way they are. But if we wanted to change the size of the font of these ticks, I use this method called tickparams. And tickparams, you provide an axis which can be, I'm going to apply it to the x-axis or to the y-axis or to both. And then I can set the size of the labels with the label size parameter. So let's say I set that to 20. That's kind of big. So I'm going to set it to 14. Okay, that's a nice size label. Next thing we can do is add a grid. Okay, if I just call grid, that's going to add just a plain grid at the points of the ticks. I can use this Boolean to turn off the grid or to turn it on. And then I can say set the color of the grid. I'm going to set this one to aquamarine. Okay, that's a nice light blue grid. I can set the line style of the grid. Let's say I wanted it to be dotted. And I can set the line width of the grid. Say I wanted a very thick grid. I set it to 3. I can have a very faint grid if I set it to 0.5. Next, the labels. I can add labels along the x-axis and along the y-axis. So let's say our x-axis represents time. So I can say time in seconds and then give it a font size. I like the font size to be a little bit larger than the ticks. So the ticks were 14. I'm going to set this to 16. So now you see here I have the label along the x-axis, and I can do the y-axis as well. Let's say the y-axis is displacement, and this is in millimeters. Okay, there it is. We have the label on the y-axis. Next, the legend. I say ax.legend. That's going to give me an error because I have not yet specified what are the labels for each of the plotting elements that I have. So I do that by passing in the label keyword. And the blue line, I'm going to call it clean data. And the dots, the red dots, I'm going to call it noisy data. So now I've added labels to each one of these. And when I run legend, it adds those labels to the legend. Okay, well, again, I can change the font size here, set it to 16, for example. I can also set the location of the legend. So if I wanted it down here on the bottom right, I could just say bottom right. No, it's right, lower right, lower right. Lower right, okay? Or I could put it on the lower left, or on the upper left, or upper right. I can also here just say best. And then in that case, the program will make a decision where to put it so that it obstructs the data the least. Okay, that's the legend. Next, the title, ax.setTitle. Well, just as you'd imagine, let's just say this is the title, and then I can set the font size. Let's set that to, say, 16, and now it adds a title at the top of the plot. Finally, the spines. I like to remove some of these spines sometimes. So you can say ax.spines. Here the syntax is a little bit different. Spines is some sort of a list, and then or a dictionary that you index with top, bottom, left, and right. So if I say spines top, I get the top spine, and now I can call set visible on this and set it to false, and now that spine has disappeared. I can also pass in a list here and say top and right. Now I have removed the top spine and the right spine. And if I wanted to remove all of them, the shortcut for that is just a colon, and that removes all of the spines. Well, let's say I'm satisfied now with my plot. Next thing I might do is to save it to a file. So for that, I go back to the original figure object, and I call fig.savefig, and I give it a file name. So let's call this my figure, and I like to save things to PNG. So if you say .png, it will detect that you want to save it to a PNG file and do that for you.